Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dmitry.
We have a pleasure today to talk to Jeswin and Vivek from SquareX. Guys, please introduce yourself and tell us what you guys do.
I'm Vivek. Thank you so much, Evgeny, Dmitry, for having me on the show. I'm the founder CEO of SquareX, and day to day, pretty much figuring out the product side, go-to-market side, and everything else that a founder CEO would probably end up doing.
Hello, everyone. This is Jeswin. I'm the chief architect at SquareX. I'm responsible for designing the backend infrastructure as well as leading the implementation of it.
Great, Vivek and Jeswin. So welcome to our show. And let's start with the first question. What's the name of the offering or the product that's actually addressing the browser security on your side?
Thanks, Dmitry. The name of the product, interestingly, we've kept SquareX as well. We call it SquareX Enterprise, just to make it simple and not to have too much of brand product name confusion. And really what we are building is a browser detection and response system, similar to an EDR is an endpoint detection and response system. And what we do is help enterprises detect, mitigate, and threat hunt web attacks happening against their employees when they're on their browser, doing their online work on a day-to-day basis.
This is definitely important. I think we more and more time spending in the browser. So it's definitely an important part to do. And there's many different attacks, architecture ideas that are basically work differently than they worked 20 years ago. We're not in the office all the time right now. We are moving from place to place as well. So it's a bit different architecture and design. Having said all this, we are a podcast about architecture. So we definitely want to understand your architecture and your design, how you guys decided to architect your solution and how it's working. So please describe.
Yeah, that's a great question, Evgeny. And just to take a step back, if you look at web attacks which are happening in the browser, I think for any security product, the most important thing is to get as much context and visibility as possible. And that's really where in the browser, you have DOM events, browser events, user interactivity, a bunch of all of these things going on and which keep changing literally on a millisecond basis. So our perspective when we were actually building this browser detection response system was to go ahead and be a browser native security product, a first-class citizen. And what I really mean by that is we wanted to go ahead and do 95% of all work sitting on the browser itself and 5% via APIs, threat detection feeds and whatnot with our cloud service. And that kind of dictated how we built everything. So the architecture, given what we wanted to do, had to have a very powerful policy management engine, having the capability to run within the browser itself. Now, one big design choice we made right up front is we figured that if you want to go to enterprises and give them a dedicated browser, that is massive change management, a huge amount of friction. And people love their browsers, right? Almost everybody uses multiple browsers, even within organizations. So we said, look, let's make this frictionless and let's go with a browser extension approach, which can be deployed on any of your favorite browsers. So that was the very first choice is we deploy as a browser extension, though we have the ability to also deploy as a dedicated browser if required. The second design choice we made is by being a first-class citizen in the browser itself, our policy engine should have the capability to inspect and pretty much monitor any possible workflow happening within the browser itself. And to do this, we had to go ahead and hook into pretty much most changes which happen dynamically, but at the very same time, lend itself to be dictated by various policies. So the second design architecture choice we did is we wanted our policies to be very free-flowing. Been 20, 25 years in cybersecurity, the moment you have a very powerful product, it becomes very difficult for security teams to go about configuring it. So in this new age of LLMs, what we ended up doing is you could literally go into SquareX and basically say, isolate all encrypted zip files downloading from webmail. And our engine can then take that, talk to our policy manager, and actually create fine-grained policies or even rule scripts in a completely automated way, which can then be deployed. So one of the things that customers love is the fact that they can now describe a business problem or a business objective rather than worrying about the nitty-gritty details of building out these small policies. Additionally, we also felt like isolation was important. And one of the things that we built in a native way is we support both browser as well as file isolation, and which kind of allows people to have one solution for the entire kind of 9 yards of looking at workflows, detecting issues, which includes bad behavior or malicious attacks, and then go about blocking or isolating it.
So one question I have is the management component. You mentioned that everything has to run in the browser, but I'm still doing the changes in the management and they get pushed to the browser. So I'm guessing correctly that you don't need to go back to the management to understand to block or not to block. Everything is done in the browser.
Exactly. That's a great question, Evgeny. And I'll tell you, when we started talking to a lot of prospective customers, I think incumbents, the biggest issue really was that anytime you get disconnected from the internet, you're on an intranet or behind a captive portal, many products don't work because they can't talk to the mothership, the SaaS service in the cloud. So this was something we built it from a design choice perspective, is once these policies get downloaded on the browser, it'll completely work absolutely autonomously without requiring to be connected or communicate with a SaaS service running in the cloud all the time. And the only time that this connectivity happens is if new policies are pushed or old ones are modified, or there is a policy hit happening in the browser. And now we need to send back that data so that the administrators and security teams can view and look at what really happened.
Vivek, I have a question on this topic.
Yeah.
Does your extension have identification for malicious URLs?
Yeah, that's a very great question, right? Dmitry, when you look at malicious URL detection, I break it up into two parts. And the first one is what I call known malicious, which is this there in all threat feeds already, right? And that is something which works out of the box because we integrate with known threat feeds as well. Now, the second part is actually very interesting, and I'll tell you why. And this applies both to malicious URLs and files. A lot of times, what an organization may view as suspicious or malicious differs in quite a very big way. And I'll give you a simple example. Maybe you go to a website, and from that website, somebody tries to download a document, and that actually contains an Excel with a macro. Now, based upon that, would you actually consider the site and the file malicious by default? Probably not. And this is really where, Dmitry, what we've done is our policies are fine-grained enough that organizations can define how they go about categorizing a URL as malicious. So here's what we allow you to do. You could go in and say, hey, some of the common ones, which is if a site is less than 90 days old, or if there is a registration flip, or if it is hosted in autonomous system numbers, which are known to be hosting malware and things like that. So we allow you to do all of those, but additionally take it to a whole new level where imagine you could literally go in and write a policy which says, block or isolate all websites which end up loading, let's say, from Russian IP addresses. And with something so high level, we are able to go ahead and look at the stack at every level and then go about applying policies which can block and isolate. So if you're a US government website and you are worried about something loading from unfriendly jurisdictions, you could now go ahead, apply policies to do all of this. So we have that massive flexibility and granularity.
Okay. So I'll ask a tricky follow-up questions on that one.
Yeah.
In order to resolve a website and understand if it's hosted in Russia, you likely need to make an API request with the IP address of this hostname to some service to resolve it and get some metadata around this IP. So it sounds that the extension does require some communication to your backend to get this information.
So that's a great question, right? So if you look at IP address spaces, what tends to happen is there are sites where autonomous system numbers along with the entire chunk of IP addresses are available, and these get updated when there are changes. So what we do, Dmitry, you brought up a great question. Imagine having to make that check for every request, we'd actually go crazy.
Yeah, that's exactly
right. And that is really where what we actually do is, again, browser native approach. This entire ASN IP mapping, we go about creating extremely efficient search trees and binary structures, which get downloaded to the browser extension and actually are running locally inside WebAssembly modules, which is super fast. And only when there is a change do we go about pushing these incremental updates and not the entire ASN IP address mapping. And now ASNs are always mapped to geographies because they are jurisdictionally owned by a service provider. And that is how we do all of this entirely locally with very minimal requirement for server-side updates.
That makes a lot of sense, and kudos on this implementation. Very impressive.
Thank you so much. Thank you.
So let's talk about the next topic. Authentication and authorization is a very important part of any solution such as browser security. How do you integrate with identity providers?
Yeah, that's a great question. And I'll actually break it up into two parts. The first part, of course, is our product allows you to go about integrating with any identity provider, whether it is Microsoft or Google-based or SAML and a bunch of other things. And you have the ability to go about importing the users and groups and automatically applying policies rather than to recreate that entire tree locally. That is one part. The second part, interestingly, Dmitry, what we also do is a lot of organizations, unfortunately, are also getting attacked by identity attacks. So as a simple example, your device ID phishing, browser in the browser attack, adversary in the middle. So not just integrating with the identity provider, we monitor identity exchanges happening in the browser with any third-party website. And you can even apply policies to go about blocking, isolating, monitoring many of these identity connect workflows which are happening, which most organizations aren't even aware of. And I'll give you my favorite. Every employee ends up clicking sign in with Microsoft or Google or whatever your identity provider is on any third-party website as a convenience feature. And this is something organizations hate. So by the way, with SquareX, you can go about deploying a policy to actually block and isolate this.
Very interesting. But would you be able to perform the login as part of the plugin and then federate it to other websites that I'm working with, or it's not something that's supported today?
That's a great question. So I think what you're alluding to is more about, is the extension starting to work a little bit like enterprise browsers, right? Which is, can it go about doing its own single sign-on, etc. So Dmitry, what we've done as a very conscious choice is the way we look at the whole browser security space is one aspect of it is your enterprise browsers, and that's primarily about access control to your internal websites, third-party SaaS websites, and zero trust and all of that. And the other part is really the wild, wild west, the internet where attacks are happening, your employees are online and all of that. So what SquareX is really looking at, and that's why I call ourselves browser detection and response system, is really we are primarily focused on attack detection, mitigation, blocking, and isolation. Now, could we add that as an extra feature 100%? Could we do things around context-aware security with probably some small modifications? Yes. But at this point in time, our focus, razor focus, is blocking attacks, bad behavior, and all of that.
Let's switch a bit topics. And you mentioned a bit about architecture and design in the past. And I've been in network security for a long time. And I think majority of the companies still have one way or another use security web gateways. Oh, now we call them SASE as well. And I'm wondering, do you augment? Do you replace? Do you work together? Or do you see different future for basically enterprise browser and security web gateways?
Okay, that's a great question. So I think, Evgeny, what's been happening is if you go back 10 years, secure web gateways were the primary way that organizations were trying to detect web attacks happening against their employees. Now, unfortunately, secure web gateways do not have any application context, no user interactivity awareness, no access to DOM events, and a bunch of other stuff. So one of the very interesting things that we did this year is we did very thorough research, which we published as a main stage talk at DEF CON, which is Breaking Secure Web Gateways for Fun and Profit, which is where we actually showed that unfortunately there are architectural issues based upon which attackers can bypass and smuggle malware, malicious websites, and all of that through every single secure web gateway in the Gartner quadrant. The talk has been covered by a lot of mainstream media. All the big vendors are in touch with us. And that is really where none of them, at least to the best of our knowledge, have put out saying these are attacks that they can protect against. So flipping from there, our core belief is that any security system, if it has to work, has to have 100% visibility of what is happening. And this is really where, with newer technologies like WebAssembly and whatnot, attackers can go about creating client-side browser-first attacks, which server-side components will almost find impossible to detect. And I'll give you one example. At this point, if any SASE, SSE, SWG wants to detect a malicious malware, what it does is it looks at HTTP flows, and the moment there is a content disposition header or a bunch of other things, it says, oh, I see a file downloading. But now imagine the attacker is packaging the entire file as a WebAssembly module and not really as a typical file. Or maybe even better, you can go about reassembling or creating a file entirely in JavaScript. Now, all of these completely bypass server-side controls, and that is really where having a client-side web browser-first native solution allows us to look at all of this as it's happening. So to answer your question, I feel when it comes to this whole space of web attacks, we absolutely replace secure web gateways. And at this point, enterprise browsers go ahead and have web attack detection more as a checkbox, primarily relying on a bunch of stuff that Chrome itself is doing, rather than looking at fundamental ways to solve the problem. And that's really the sweet spot that SquareX is trying to attack.
I'm going to ask a very tricky question right now. If I don't use web browser, if I have a fat client, you have a Dropbox or client installed, or if the bad guys is on the device and want to do some kind of CNC control to get more information from the internet or the script going on, they're not going to use the browser. They're going to use default gateway.
Yeah. So that's a great question. And if you think about it, let's pick up a local application like Slack as an example, right? So really Slack itself is powered by backend APIs. And the Slack interface itself is not really technically a fully functional browser. And what I mean by that is the only thing that you can view in a Slack application is messages coming back and forth from the API. Similar for WhatsApp, Telegram, and all of these. So interestingly, if you look at a web attack surface, the primary things that you're worried about in a Slack is employees posting malicious links, employees posting malicious files and things like that. And interestingly, that is something, if from an endpoint security perspective, things can be picked up when files actually end up downloading. But the moment an employee within Slack ends up clicking on a link, we go back to the web browser. And that is really where SquareX once again comes into play. So for local applications, which aren't technically browsers, but basically very specific viewers of data of that application, I think the web browser surface itself doesn't exist. Browser attacks itself don't exist. There you're worried about malicious links, but once a click happens, we take over. And files which when get downloaded, EDRs take over and XDRs take over.
I have a question about it, and I was wondering, there are a lot of tools that actually having browser embedded in them, and they're doing preview, especially you see it in mobile devices, where you have the browser from Facebook, when you have the browser from LinkedIn, when you have the browser, right? So how do you go about these ones when it comes to browser security?
Yeah, so this is an interesting question. So on client-side devices, you even have progressive web apps, right? So you can go to YouTube as an example and say install as an app. And really that just opens up within the browser. So Dmitry, in cases on the desktop, when primarily you have progressive web apps, what tends to happen is when you actually try to open something in a YouTube locally installed app, it is technically opening up the browser. And the most interesting thing is our browser extension and other extensions actually keep running. So if you actually ended up using a YouTube progressive web app or even third-party ones, when that app opens, we still are in control because it is just a browser view, right? Now, when it comes to mobile devices, the good or bad is unfortunately depends a lot on what the platform provider themselves allow. And I think that's a massive limitation for all security vendors, is because literally Apple doesn't allow you to do low-level things. Now, what is the trade-off? SquareX at this point in time, we can be deployed as part of Edge and any browser which allows browser extensions. But the caveat over here is, of course, in mobile devices, things are locked down fair amount. And that's really where one of the things that we are hoping to look at is applications where we can enable accessibility mode. So SquareX may deploy an app, and an app having accessibility mode can now look at what is going on the entire device, how the views are changing and all of that, and hopefully try to put itself somewhere in between. We don't have that. It's on the roadmap. But what you brought up, of course, is a major challenge for the entire security community.
Yeah, this is definitely the focus right now with all the recent attacks. So let's switch to the next topic, which is how your solution augments email security solutions, right? So either getting
Yeah.
a malicious email or getting a malicious link in the email, or even employees trying to get some sensitive data and sending it over the email, right, from the browser, because everybody works in the browser today.
Correct. You bring up a very good point. And Dmitry, I think this is the place where I would love to show you some demos as well, because again, proof is in the pudding, proof is in seeing, and I wouldn't want to bore your users beyond a point with just talk.
We
So
never
let me
say no
break.
to the demos.
Yeah. No, amazing. So I think that's really where, let me actually show you a couple of, we'll take up maybe 2 quick demos. And that's where I think Jeswin is here to help us. Jeswin, the very first one we can actually see is Dmitry brought up email, webmail and all. So maybe the one with encrypted file downloads, right? You can share the screen, and Dmitry, I'll give you a background while this is going on. So the use case that I wanted to pick up at this point, if you look at email security gateways, if somebody sends you an encrypted zip file and maybe the attacker is now sending the password in an out of band way, right? Maybe they SMS it to you, something else is going on. And that is really where I think email security gateways can either just block or allow or just do one of these. So here's a perfect example. We pick up webmail. And at this point in time, you received an email with an encrypted zip file called confidential.zip. We've kept the password in here, but this could have been out of band as well. Now, at this point, all you can do is either allow or block with email security gateways, nothing more. So let's show you how this works with SquareX. So we go back to our enterprise terminal, and this is really where we can apply policies on different browser actions. So we'll pick up one on file download, and Jeswin will go about creating a free flow policy, let's say to isolate all encrypted zip file downloads from mail.google.com. And the key thing I want everybody to notice is you might never have seen a policy being written this way. This literally looks like a policy description and not the policy itself.
That's the policy copilot right there.
Yes. So that's really where what we've done is we know that security teams want to focus on business objectives. And you can now go about compiling this. And if we scroll down, you will end up seeing that we've automatically created the rules. And this is really where we go about detecting the file extension and all of that. And then we can go about applying this policy, let's say to customer support. And if you notice, immediately we block the download and click on requires password. So the most interesting thing that we can actually do over here is the fact that we could go about putting stuff in right here itself. So let's say open and save file viewer. And at this point in time, we are using file isolation right there in the browser itself. And you can now double click on this. You can enter the password.
Where this is running, is it running on your side?
So this is currently, Dmitry, running on our cloud service inside isolated containers, where we go about like reflecting back the entire GUI.
Or BI
So
pretty much.
That you're sending back pixels right now. So when it came to the point where there's something that potentially could be contradicting the policy and it could be something that dangerous, you immediately took that threat away of the computer to your cloud system into a sandbox in a way where you executing and running it. Very interesting. That's a very unique approach.
Exactly. And to your point, why? I've felt like if a security solution comes in the way of productivity, imagine now that you're downloading an encrypted zip file which gets blocked and now you have to go to IT. That is crazy. And we basically, nobody wants to do that. Organizations hate it. Security teams hate it. And that's really where what we've done is we said, why not just go with the workflow, but keep everything safe? So we block the download, but give the user a way to view it. And a lot of solutions in secure web gateways don't have file isolation. They have remote browsers. At the very same time, the few that have, they will convert everything to a PDF, which is even more nonsensical, right? An Excel in a PDF is useless to, finance team.
It breaks everything.
Yeah. Now, if we go back to the enterprise portal and look at the detection itself, what you would see is that we've been able to look at these events. And similar to what you would see in endpoint security, we are now showing you an attack graph. And because we reside in the browser, Dmitry, look, Evgeny, something very interesting. We even picked up the email address which sent you the email which we picked up via our webmail. So we deeply integrate with Google Workspaces, Office 365, and many of the popular services which enterprise use. And we can pick that context up from the page. And it clearly shows you went to mail.google, tried to download an attachment, which was an encrypted zip file, which got isolated. Now, as these attacks can get complex, we have our Copilot, which immediately gives you an attack summary.
Oh.
So yeah, this is something you could immediately send to your management team. And if you look at the summary, it clearly says August 27, 2024, SquareX detected, mitigated potential this. The user ended up clicking, trying to download. And that is really where we triggered an isolation policy. And by the way, we can even do automatic remediation if you turn that on, where now we can blacklist the same zip file across all your enterprise employees, including email itself, which is now if you open up an email and it comes from the same user, we can actually block that email from getting viewed.
Does this mean you going back to Office 365 and tell them to block, or?
You brought up a great point, Evgeny. So because we sit in the browser, right? If you block the user from interacting with that email, you essentially blocked access to anything potential bad happening. So eventually we want to integrate back, but even without it, we won't allow the user to open an email on webmail from phoebiani@gmail.com.
Makes sense. You showed an isolation right now, and when you basically trigger an RBI. Many RBI solutions, and I'm not saying you're RBI, I will isolate everything or isolate some of the work. Tell me more about the isolation. Is the isolation triggered by policy? Is the isolation done in RBI? Or there are some parts that are done in the browser? How do you decide what to do and where?
Yeah, that's a great question. So I think when you look at remote browser, or what we call remote file isolation, RFI, primarily triggered from policies. And Evgeny, to your point, if you isolate everything, experience goes down in a very bad way, right?
Yeah.
And that's really where let's pick up file and website isolation as two different topics. So file isolation, what we end up doing is our file scanner runs entirely in the browser. And Jeswin, while I'm talking, could you just apply a policy for malicious, or let's say Office documents with malicious macros, and show that demo? So what we do is our file scanning technology runs within the browser as WebAssembly. And let's say somebody is downloading an Office document. Right there in the browser, we can look at it and say, does this contain a macro? If it contains a macro, does it potentially contain functions which could be malicious? If so, we can actually block things locally entirely, and you'd never have to worry about sending anything back. So it's also privacy first, which is all the analysis happens in the browser itself. Now, if you go about setting up a policy which says isolate all Office documents with macros in it, we can go about doing that as well. So just going to apply the policy, and let's go through the demo really quickly. Now, similar to that, Evgeny, what we've done is with browser isolation, exactly the same, triggered by policy, where you could go about figuring out, hey, does this site warrant an isolation? So I'll just show you the file one really quickly. It takes a few seconds for the policy to update. If you notice, we detected this to be a malicious document. You can click on it, and based upon that, things basically just get blocked. Now, if we go back to the admin terminal, you will actually see that we've been able to figure out that this was malicious. And one of the interesting things we've even done is this entire analysis of the macro is also available here. So if you notice, this says there was a shell command in that, which is suspicious. The executable name is ui.exe. Justin, can you please mark those on the screen? And the next one, we've also picked up the IOC. The interesting part, Dmitry, Evgeny, is this was done entirely client side with our file scanner, which is looking at the file in real time and then deciding what needs to be done.
Can you go back to the email, to the malicious email?
Yeah. Let's go back to the email, Jeswin. Go ahead.
Can you hover over the file? Click on the plus to drive icon, the second one, not the download. Yep. What happens in this case? Click now and organize, or just open it in your drive and try to download it from there.
Go ahead, try to download it from there. And you'll see something very interesting.
That's what I'm very excited to see.
There you go. Detects it once
Nice.
again.
Very impressive.
And Dmitry, I'll tell you how this actually works, right? Just flip back to the enterprise screen. The way this actually works is we are looking at the low-level browser events when the network communication is happening. And that is really where, irrespective of where the file is hosted, eventually when the file comes down, we are able to intercept it and apply our file analysis right there. Now, we do something even more interesting, by the way, which I feel is industry first. Go back to detections and click on attack vision. So one of the things that we've built out, and we are filing a patent on this, is a lot of times for certain susceptible user groups like customer support, organizations may want to turn on enhanced visibility because the attack could be so complex that you don't even know what really happened. And when you do that, Evgeny, Dmitry, this looks like we deployed an agent to record a screen. That's not it at all. This is all happening via the browser extension using a lot of DOM magic. And that is really where we give you the illusion that we are creating a video and showing you what really happened during the time of the attack.
You're reconstructing the DOM elements?
So we do a bunch of interesting things because we're filing a patent. I can't reveal more, but I'll give you a high-level view. Is the DOM has enough information to recreate the screen and for us to figure out how things have been changing. And if you have a smart interpolation technology somewhere in between, it gives you an illusion of a video.
Yeah, very interesting. Okay.
And I'll just show you one more demo of the power of the policies, which is website. So Evgeny, you had asked about that part. Just when you can go back and show the isolation example for websites. And in this case, we'll switch over to a script rather than rules. And what we are trying to show is many security products have hundreds of parameters, but that isn't enough. And that is really where we wanted the ability to go about monitoring and inspecting any web workflow, which basically means free from scripting. So our policy engine allows that. And here's an example where we basically mentioned isolate or Southeast Asia TLD websites apart from well-known brands. This is crazy business specific, but very technically non-specific. And now when we go about applying this, our engine understands that parameters can't be used, and it goes about looking at building a free flow script to create this specific rule.
I'm curious which domains is going to block now, and if we can see it. Okay, we can see it. That's the domains.
Yeah,
Very nice.
so you could just go about this when applying the policy. And the key thing at this point in time is if you open up any Southeast Asia TLD, what will end up happening is you'll actually see that we don't allow you to open. And this is really where we automatically run browser isolation. And you can completely go about just doing everything internally. Now, we've added one other interesting thing I want to touch upon, which is a lot of times employees want to go about doing their own research where they want to go about opening sites which they worry about, right? Unfortunately, you can't go to an admin and ask for a policy. So you can actually turn on what we call disposable browsers in the settings. And when that happens, the employee himself has an opportunity to go about launching a disposable browser. So he could just click on our extension. And if you notice, now you can launch a disposable browser similar to a VPN on any of these locations. The best part of this is employees who know that they are going about doing research and going to places which could be concerning can start to learn to act more responsibly on your own. And this is interestingly also like a poor man's VPN replacement, so that your employees don't have to go about installing some of the consumer ones which open you up for more attacks.
That's definitely very interesting features, or even capability, foreign features that to make our life much more secure. So let's talk a little bit about editing documents like Google Doc online. What kind of capabilities you bring into this space? As example, if I'm now trying to copy paste a huge list of credit card numbers into some online Google Doc, or maybe the other way around, I'm trying to copy some data from Google Doc with social security numbers. What can browser do in such case?
Yeah, that's a great question. And I feel like web DLP in the browser is a massively unaddressed space. And Dmitry, you won't believe this, many folks that we speak to, many organizations, these are some of their very first use cases, which is we don't want somebody to copy paste into generative AI websites, copy code out. And sometimes even more interesting ones like you don't want uploads to happen to your personal Google Drive, but only to your company Google Drive. So one of the things that we do, Dmitry, in this is we are able to look at multiple identities in the browsers concurrently and apply policies specific to that. And what I mean by that is we are able to differentiate that you are concurrently logged in to your personal Gmail, to your personal Office 365 alongside your Office one. And so your admin could go about putting out a policy which says block all uploads to your personal Google Drive, but not the company one. Just if you have a very short video demo which you posted, maybe you can just quickly show it. Similarly, Dmitry, we have the ability to not just look at regular expression based DLP, but one of the things that we've innovated on and we are pushing out is basically now with generative AI, LLMs, and all of that, we can do a lot more. Also, at the very same time, our DLP even has document similarity algorithm. So imagine you've downloaded a document, you've made some edits, and now you're uploading, which means the hash is different, things are different. You can set a threshold based upon which we can detect those similar documents, and we can then go about reporting and blocking those as well.
Interesting. I'll drill down a little bit about the LLM.
Yeah, of course. Yeah.
I'm assuming it's your own LLM model that you're basing on some open source or self-trained one, or you actually using some public LLMs use case?
Yeah, great question. So I think what we've done is we've opened this up for a potential customer to decide, which is they can basically tell us if they want to go about deploying this to their tenant, allow us to use open source models or free models. And that way we have an option between Llama and a couple of other paid ones as well, Gemini and others. But the whole document detection and everything, we've used kind of vector-based comparisons, cosine comparisons, and all of that. And all of those algorithms are actually, once again, running entirely in the browser with a very small, lightweight server-side component to work with. So our North Star is we are really trying to push what you can achieve in the browser in a way where this can scale and you don't have similar issues like secure web gateways do, which have file size limits and file type limits and all of that, because there's only so much processing that they can do per request.
Makes a lot of sense to me.
In the beginning of the conversation, we touched base on identity. And right now we have many companies that allow people to bring their own device. Or in some cases, people use mobile devices as well. Tell us more about how you guys address this particular situation, problem, or whatever you want to call it.
So I think, Evgeny, you bring up a great point. And both Chrome, Edge, both of them have ways by which you can enroll the browser, even if it is on an unmanaged device. So basically what happens is you are managing the browser profile, even on an unmanaged device. And then based upon that, our browser extension and everything can be deployed as well. So this ensures that you aren't necessitated to go about deploying a full-blown enterprise browser. Rather, you can actually use your own. And interestingly, Google, Microsoft, all of these folks are pushing for this, encouraging this. And that way, you can actually have your little trusted piece on an unmanaged device. Now, mobile devices, of course, similarly are always different. And that's really where if you have Edge managed or something, even though the device itself may not be, and you can do browser enrollment versus device enrollment. And based upon that, you could still at least have control over what is happening within those browsers.
Thank you.
Your product eventually is an extension, right? For a browser. Now, we have a lot of extensions that we're usually using. Password managers, other extensions that other tools are installing. How do you make sure that your extension covers also what these extensions are doing?
I think, Dmitry, we try to be very conscious that we only want to overarch on use cases, which again are about like detection of attacks and things like that. So I'll tell you, when you have like last password managers, etc., what we tend to do is not interfere with their password management, but any time that a user ends up trying to use it on a certain website, we try to figure out if this was a malicious website, is a possible session hijacking or a credential stealing attack happening. We look at other browser extensions where we have a full section where we can go about issuing a policy where you can say browser extensions which are asking for certain permissions should get blocked and all of that. Perspective here is that you want the enterprise to still function as they were, but ensuring that browser extensions play ball as well. So if you notice, we on the left-hand side, this is the extension section. And we have a massive number of these things that you can apply. Rather from very simply the author, category, description, the permission sets that are required, install type, is this a featured extension? Is this a trusted publisher? So the whole idea really was, Dmitry, to your point, that browser extensions come in so many flavors. We wanted enterprise to be able to slice and dice these policies in any arbitrary way. And that is what allows us to now block other extensions as well.
Interesting. So if I have an extension installed and it's violating the policy, you actually can block it from usage of the user.
Yes. So we can go about blocking that extension. Interestingly, we can also go about blocking network access to extensions where, let's say, a certain extension is trying to communicate over the network and all of that.
Can you do like a risk assessment to understand if you have potentially dangerous extensions?
So that's a great question. So I think on the browser itself, to be able to do that starts to become a little tricky. But here's what we did. On the cloud side, we've created a modified version of Chrome, which taps into every single browser extension subsystem events. And those events end up flowing to our algorithms where we try to see if these extensions are doing something suspicious. We use that as a threat feed. So anytime that one of our customers is installing a new extension, we automatically do that threat assessment and decide whether to autonomously go about alerting them or outright blocking and then telling them like why we did it. One interesting thing I want to add is even a very well-known extension can flip to be malicious because it's very easy on the Chrome store to go about buying extensions and transferring ownership. And this is a very big issue at this point in time.
So this is actually leading us to last question. Every enterprise want to see metrics, they want to see reports, they want to understand what's happening. Tell us about capabilities, what you can report to show enterprise what's happening in the company.
So I think, Evgeny, you bring up a great point, and that is really where I think what we've done from an innovation perspective is most organizations, when it comes to web attacks, you will see security IT teams may not always be trained to interpret those web attacks. So one of the things that we've done is rather than just copy paste metrics and basically say, here was this complex session hijacking, which ended up using WebAssembly. What we do is we use AI to go about creating full description of the event in a human understandable way so that you can paste those summaries to your management team as well. And then along with that, in our reporting, we automatically mention the IOCs that we've detected, including auto remediation measures, which if you turn on, along with the report, that can automatically be applied. Now, of course, we also do most of the other ordinary stuff, which is go about connecting to your SIMs and all of those where you can now create report structures like you do across enterprise security products and everything. But our key differentiator is we use our AI agents to go about creating reports very contextual to the attack and very specific to what you want. So you can go in and say, I'd like to create 3 different kinds of reports. The first report is what I'm going to share with my CEO and board. And in that, please focus on the high-level attacks, the impact, and the fact that we have blocked it. And then create a second-order report, which is more for practitioners, which is I want to tell my security team what kind of IOCs were seen and how they should apply this across various network devices and whatnot. So that report will focus from a practitioner standpoint. And the third, interestingly, is what we call user awareness reports, which is, let's say your entire sales team was targeted on LinkedIn via malicious document, which is masquerading as something you can open and probably do a buy order. We create a report which you can send and say, our organization is under attack. Here is a user awareness friendly report, which you should go through and understand how to go about mitigating this or not falling prey to it.
Makes sense. Thank you.
Thank you so much.
Guys, thank you very much. We were planning to record for half an hour. We ended up recording for much longer. Very interesting session. A lot of good information, a lot of innovations. Thank you very much.
Thank you.
Thank you.
Thank you so much, Evgeny. Thank you, Dmitry.
Please remember to subscribe to our podcast and join us for our next episode.